Good morning, children. Welcome back to our math session. Our today's topic is exercise 6.4, question number 5. Let we start. Let we start our question number 5. Find the least number which must be added to each of the following numbers so as to get a perfect square. Also find the square root of the perfect square so obtained. Okay. So in question number 4, we already done that. The number must be subtracted to each of the following numbers so as to get a perfect square. Isn't it? So that case it was very easy because we only find the long division method of the given number, and whatever remainder we got, that remainder we have subtracted from the given number. Then we got the perfect square, isn't it? But in this case, first we have to do the same thing, means long division method, and we have to find the remainder also. But with the remainder, nothing we have to do. But in that case, we can understood that the given number is not a perfect square. So here we have to add it. That means more than the given number. We need a number that is greater than the given number. So whatever quotient you are getting, that is lesser than the next square, isn't it? So we have to find the square of next number, the square of next quotient. For example, if we are getting as a quotient 10, then we have to find the square of 11. Okay. Then after that, take the difference of 11 square and the given number. Means we have to find how much numbers. Yeah, what about the number? We have to add it with the given number, that the given number become a perfect square, isn't it? So for that, it's a number greater than the given number. So how could we get? First, we have to find the perfect square number that is less than our given number. Then we have to find the next perfect square number. Then take the difference of next perfect square number and the given number. So whatever difference we are getting, that we have to add with our given number. So that is the perfect square. Understood? Yeah, whatever may be the next perfect square of the quotient. That is our new perfect square number. Clear? Let me see. So here first question is 525. So first we can take the long division method of 525. So first number is 5, 2 2 ja 4. 1 is the remainder and 25 we are keeping down. So in 125, the square of 2, 4, we already divisor we got there. Now next 4 is there, means it maybe you can multiply like as 40. Okay. So if you are doing the 3, 3 4 the 12, 120. But 3 3 jar 9 also is there. So 129 will come. So 3 is more than 125. So we can multiply with the 2. So 42 into 2, that is 84. Now what is the remainder? Remainder we got 41. Here remainder is 41. We can do nothing with the remainder, but we can understood that this 525 is not a perfect square because remainder is there. So we got a quotient. That means the square of 22 is less than 525, isn't it? So next perfect square, what is there? That is 23 square. So next number is 23 and we have to find the square of 23. So 23 square is equal to 529. Then the number to be added means we have to take the difference of 529 and the given number, that is 524. So 529 minus 525 is equal to 4. So new number is 525 plus 4. That is 529. So root of 529, that we already knows, that is 23. Okay. So what is the smallest number we have to add here? That is 4. Now you see the answer how you could write. So here remainder is 41. It represents that the square of 22 is less than 525. Next number is 23. and 23 square is equal to 529. That you have to find, means 23 into 23. That is equal to 529. Hence, the number to be added, that is 529 means 23 square minus given number 525. That is equal to 4. So, the new number obtained is 525 plus 4. That is equal to 529. Thus, square root of 529 is equal to 23. Clear? Now, second question, that is 1750. Here also first we can take the long division method. So, first number is 17. So, 4 4 are 16. Remainder is 1. 50 we can keeping down, so 150. So, here a divisor double of 4, that is 8. Now here if we take 2, so 2 8 is 16, 160 will come, isn't it? So 1 is the smallest number. So 81 into 1, 81. So remainder we are getting 69. So here the remainder is 69. Now see the answer, how could we write? It represents that square of 41 is less than 1750. Isn't it? The next number is 42 and 42 square is equal to 1764. 42 square you have to find. Okay. So inside you can solve 42 into 42, that is equal to 1764. Hence number to be added to 1750, that is equal to, we have to find the number what should be added with 1750, isn't it? So how could we find? We have to take the difference of 42 square and the given number. So 42 square is 1764 minus 1750, that is 14. So we can add 1750 plus 14, that is equal to new number, means 1764, that is the square of 42. So required perfect square is 1764. So root 1764 is equal to 42. Clear? Next, third question, that is 252. First, take the square root of 252 by long division method. So here first we are taking 2. So 1 1s are 1, remainder 1. 52 we are keeping down, so we will get 152. Now double of 1, that is 2. Now we have to put such a number that is equal to 152, yeah, less than 152. If we put a 6, then it will come more than 152. So we will put a 5 there. So 25 into 5 is 125. Now remainder we got 27. So it represents that the square of 15 is less than 252, isn't it? So the next number is 16 and 16 square is equal to 256. Hence the number to be added to 252 is equal to 256 minus 252, that is equal to 4. So the new number is 252 plus 4 means that is 256. So required perfect square is 256 and the square root of 256 is equal to 16. Clear? Next, fourth number, 1825. So the division of 1825 is, first number is 18. So 4 4 are 16. So 18 minus 16, 2. Now 25 we are keeping down, so we will got the number 225. Now here divisor is double of 4, that is 8. Now if we put 3, then it will be 240, isn't it? 3 8 are 24, so that is greater than 225. So we will keep 2. So 82 into 2, 164. So what is the remainder? Remainder is 61. Okay, so it represents that the square of 42 is less than 1825. So what will be the next square? That is 43. So 43 square is equal to 1849. Hence the number to be added to 1825 is 1849 minus 1825. That is equal to 24. So new number is equal to 1825 plus 24. That is equal to 1849. So the required perfect square is 1849 and root 1849 is equal to 43. Clear? Now we can solve last number of this question, that is 6412. So first take the division. First number is 64. So 8 8 are 64. There is no remainder, isn't it? Now 12 we can keep down. So 8 2 are 16. So 12 is less than 16. So we can keep 0 there, isn't it? So a remainder we are getting 12 itself. So here the remainder is 12. It represents that a square of 80 is less than 6412. So the next number is 81. So the square of 81 is equal to 6561. So the number to be added 6561 minus given number, that is 6412. So that is equal to 149. So we have to add with 6412 plus 149, we will get the perfect square, that is 6561. That is the square of 81, isn't it? So the required perfect square is 6561 and root 6561 is equal to 81. Clear? Here we are completing this session. Okay. So thank you.